Hello everyone, welcome to the third interaction session of network analysis. I am your TA Dibanita. So in this week you have been taught about the different AC circuit, solving of AC circuit, right? Uh, with sinusoidal input. So we'll be solving three problems based on what is there in the course content this week. So the first question that we have for today is um, we have a circuit in which a capacitance, an inductance, and a resistance are connected in parallel to each other, and there is a sinusoidal voltage given in terms of like the magnitude and the angle given here, which whose frequency is also given in radians per second. What you have to do is calculate the various branch currents which are given here in terms of IC, IL and IR. You have to calculate the branch currents and the phase angles. Also at the end you have to estimate the active and reactive power that is supplied by the source, the voltage source that is given here. So so could you guys try this one out? Anyone wants to suggest how we should start? You can unmute and speak or put it in the chat box. How are we going to come up with the currents, that the branch currents that are here? Anyone? I'm audible to you, right?
Yes, ma'am.
Okay. So how should we start? See, in order to calculate the branch currents, we have to calculate the current that is flowing through here, right? Once we know the source current that is coming out, we can easily calculate what is IR and thereby IL and IC, right? Since the other parameters are given, like the impedance, the reactance, and the resistance, etc., are given. So we should try to find the source current that is flowing here. So since this is an like AC circuit, let's first calculate the different, like for the capacitance and the inductance, let us calculate the reactance. So for capacitance, the conductive reactance is given by Xc is equal to, anyone wants to go?
Divided by omega j omega c.
Right. And J, or minus J by omega C, right? So let's calculate Xc first. So Xc here, omega is given as 200 radian per second, right? So since it is given, the value of omega is given, you can calculate 1 by uh, 200 into 0.625. Now this is in millifarad, so 10 to the power minus 3, right? What is the value? So let's calculate this.
0.125.
Yeah, 0.125. So if you just simplify this, 1 divided by 0.125 is 8. Okay. Like to calculate this particular current, if we can get the net like resistance or a net impedance across this branch, we can calculate, we can simply have one single loop and we can calculate the total current that is coming through from the source, right? So since these are connected in parallel, we will simplify the circuit. For that, we are calculating for each of the branches. So let's calculate for XL. XL is j omega L, right? So omega into L, it is again 200. L is 40 millihenry. So this is 800, 8000 into 10 to the power minus 3, or 8. So if you see, like if you just consider this, up to this much, the circuit up to this much, these two branches are in parallel to each other, right? So if since both this value kind of came to be same, let us just see if it is possible to get rid of this part of the circuit. So like up to the point, let's say a dash, if we calculate Z, it is XC parallel to XL, right? Is it right?
Yes.
Yeah. So XC is minus J into 8. So like I'll just write it like this: XC XL by XC plus XL for the parallel, like just calculating for the parallel branches. So XC is minus J into 8 and XL is J into 8 by minus 8J plus 8J. So the denominator here cancels. It becomes something by 0, which is equal to infinity, right? So this portion of the branch, which is given as AA dash, this entire branch acts as a very highly, like it has a very high impedance, right? So it is almost as if it's an open circuit. We can consider it because it has infinite resistance. If we consider this part, Z equivalent is infinity ohm. Are you getting it?
Yes, fine.
Yes,
Yeah.
ma'am.
This is the rest of the circuit. So this is 30 ohm and this is 70 ohm. So now we can just solve only this part of the circuit and calculate the total current. Let's say this is I, that is flowing in the circuit, right?
Yes, ma'am.
Yeah. So what is this current I?
50 by 100, so it is 0.5 angle 45.
Right. So since this is only two resistors are there and the voltage is given, I is equal to V by the total R. So it is 50 angle 45 by 70 plus 30. That is 0.5 into 45 degree. So now that you have the current coming through this branch, is it possible to calculate IR, IC and IL? Could you please try calculating that? You have the net source current that is coming out. That is 0.5 angle 45 degree.
Uh,
Ma'am, won't
One
it be
plan that
zero,
I
ma'am?
had was multiply that 30 ohm with this zero point 0.5 angle 45. That
Mm-hmm.
will give us the particular voltage drop across that parallel branches.
Yes,
Then maybe we can use that to find out the other currents.
yes, definitely.
Ma'am, why can't we take as zero, ma'am? Since equivalent impedance results to an open circuit, so why
Yeah.
can't we go as zero current?
Sorry, zero current as in talking about, like, so this is kind of a situation like, you have been taught about resonance, right? So there will be
Yeah.
actually current flowing back like through this particular loop, but this source current won't be like acting upon it, because it will appear as if there is a very high impedance connected to this particular terminal AA dash. So there will definitely be current among this uh, LC circuit, but it will resonate. So the first part, what is the value of IR?
That will be the same as the current which is previously has been found, zero point 0.5 angle 45.
Exactly. So this particular current is only flowing through this circuit, right? So whatever this I value that we have calculated, that will be equal to IR, which is 0.5 angle 45 degree. So it's the magnitude here is 0.5 and angle is, so IR is equal to 0.5 and theta 3 is equal to 45 degree. So now try calculating IL and IC. Please note that there will be a current IL and IC. You will have to calculate. I'll give you 2 minutes to think, then we'll move ahead with the solution.
Do we approach this with current divider rule?
Um, See, yeah, you can calculate using current, like not exactly current divider. So what you can do is like, so the a particular current I will be flowing through this circuit. You can calculate the voltage across AA dash, right? Which will be similar to the voltage across these two nodes and this two node, right?
Is at 1.625 angle of minus 45 and plus 45.
Sorry?
The final solution IL and IC, they
Yeah.
are 1.625 angle minus 45 and plus 45.
Yeah, it's like, uh, okay. So it's one angle is 135 and minus 44 as per as I remember. But okay, let's see. We'll solve and we'll figure out. What is the magnitude that you got? Did you calculate the magnitude of IC and IL?
It is 1.625 angle minus 45 for IL and then 1.625 angle 135 for IC.
1.6. It's close, but I think you're okay. Let's see. We'll do it. So whoever has joined late, I hope you're following what I have written. If not, you can ask right away. We have just like started a couple of minutes ago.
Ma'am, can you summarize this question?
Okay, so basically, an RLC parallel circuit is given. I'll just go to the next page. So this is the RLC parallel circuit that is given, and the source voltage is mentioned. This is a kind of a sinusoidal voltage, right? So the RMS value and the angle is given. What you have asked to calculate is all these branch current IC, IL and IR and their phase angles, theta c, theta l, theta r. The frequency is also given. So we have started by calculating the total current that is flowing from the source, because once we know that, we'll be able to calculate the rest of the parameters. But when we started solving, we observed that the value of the capacitive reactance and the inductive reactance are both same. They are 8 and 8. So basically this circuit is acting as a resonance circuit, right? So basically the point, this A and A dash, this across this terminal, it will appear that is there is an infinite resistance. So it will not, like, whatever the current that is coming out of the source will flow through this circuit. That is how we have calculated I. Now how do you go and calculate IC and IL? The only thing we can extract from this circuit is that the node voltage across A and A dash will be similar to the node voltage across this inductor and the capacitor. So once we know the node voltage, we can calculate the branch reactances and we can calculate IL and IC, right? Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. So anyone else calculated IC and IL?
Ma'am, RMS value of voltage and current means Vm by root 2.
So you have to calculate everything in RMS. Like here also this 50, this magnitude is given in RMS value only. So it doesn't matter. You just have to calculate.
1.875
Yes, yes,
angle minus 45.
yes, you're right. So let's see if someone put something in the chat. Yes, Prakash, you're right. So two of you have already calculated. So I'll just go ahead and solve it then. So we have this current that is coming up from the source, I equal to 0.5 angle 45 degree, right? So we can calculate the voltage across this VR. So VR will be the current that is flowing through. So since this part of the circuit is in resonance, so the entire current is flowing through this branch. So it is IR into R. IR is 0.5 into 45 degree and R is 30. So 15 into 45 degree. This is voltage across this resistance. Now since they are all connected in parallel, so VR is equal to VC is equal to VL. All this will be equal. They are parallelly connected. So if you are to calculate, suppose IC, it will be the voltage across this capacitor by the total branch reactance. So it will be VC by XC. Now VC and VR are equal. So we have calculated VR to be 1545 with angle 45. So 15 angle 45 degree. Now what is XC? We had calculated it to be minus J into 8, right? Now if we just calculate this in polar coordinates, so it is 15 by 8. Let's take out the constant part. This is 45 degree. Now minus J can be written as
Minus 90.
minus 90 degree, right? Because let's say Z equal to 0 plus, sorry, 0 minus 1 into J. So if we take out the angle of this theta of this, it will be tan inverse of 1 by 0, which is infinity. So it will be equal to minus 90 degree. So this is minus 90 degree. Now 15 by 8 comes out to be
1.825.
yes
875, sorry.
875.
1.87.
1.875. The angle, if we take it up 45 degree plus 90 degree, that is
135 degree.
1.875, 135 degree. So we have found IC. Similarly, you can calculate IL. IL will be again the voltage across the inductor by XL. Voltage is same, 15 angle 45 degree. We also have the reactance of the, it is J into 8. So it is similar to it, 15 by 8 and angle is 45 degree. And J can be written as
90 degree.
90 degree, because in this case it will be Z equal to 0 plus J, that is tan inverse of 1 by 0 or tan inverse of infinity. So theta Z equal to 90 degree. So like either, yeah, so yeah, we have, let's calculate the magnitude in positive values itself. So it is again 15 by 8 is 1.875 and angle is minus 45
Minus
degree.
45.
So like in case of an RLC circuit, like for example, if there is, suppose this is the current axis, or in case of like if it is a resistance, the voltage and the current will be in the same axis with phase angle to be 0 between them. So you see in this case, when we calculated IR, where is IR? Yeah, this is IR. So IR we got a phase of 45 degree and the voltage is also has a phase angle of 45 degrees. So basically between the current and the voltage there is no lag. So both are in the same axis, right? But whenever there is an inductor or capacitor, what will happen? In case of when there is an inductor, what happens is current will lag voltage by 90 degree, right?
Pure inductor
Yes,
will
yes.
lag by 90 degree.
If it is a pure inductor. So in this case, what happens is like if we like draw in terms of the axis, since it has an this voltage is an angle of 45 degree, so it is somewhat like this V. The IR will be also along this direction. IC will be somewhat around this direction, and IL will be along this direction, right? Depending on whatever the angle is. Like in this case, so this is 135 degree for IC. For IR it is 45 degree and for IL it is minus 45 degree. So this is how you can also recheck your calculation if everything is fine or not. Now in the question it is given, we have to estimate the active and reactive power supplied by the source. So what is active power?
I square R directly we can multiply and
Yeah, like whenever there is a like, you know, whenever it is given in terms of a polar coordinate, like the angle and all is given, like it's best option to use like vi cos phi, or write in terms of, you can also write I square r, but then again the angle you have to take care of. So the power triangle in case of here it will be like this. So let's say, so the real
as
component is the,
voltage and the current are in phase, I was just current angle also is
yeah,
45.
yeah, so phase
Then
angle
there
is
will not be
0.
any lag between voltage and current.
Yes, definitely. But what if like you know, the current here, like it was not an, I'm just trying to say for a general circuit, like what if we did not have these two resistance and sorry, the capacitor and inductor in resonance, then there would be some component of it, right? So I'm just trying to like, you know, teach the general formula instead of going it for this specific problem. What you're saying is fine, because anyway phi will be 0 here.
Yes.
So this is the reactive component, the imaginary one, this is the active component, and this is the apparent power, right? This is in watts, this is in volt ampere reactive, and this is in volt ampere. So in this case, active power is Vi cos of phi, and this phi is equal to the angle between the angle of the voltage and the current, the angle between the voltage and the current. So in this case, theta V minus theta R, which as someone has just said, in this case is equal to 0 degree. So what is the active power?
50 into 0.5. So it is 25.
25 watts, right? What is the reactive power?
0.
Yes,
It's 0, right? Because XL and XC are cancelling it out.
yes. So the reactive power is Vi sin phi. So in this case, sin 0 is 0. So the reactive power is 0. So the total power that is getting supplied by the circuit is net is 25 watts. So I hope this everyone has done. If anyone wants to ask anything, you can ask. Otherwise, we can move to the next question. This particular reactive and active power I have written in terms of the formula Vi sin phi and Vi cos phi, because just in case like this is not a resonance circuit and you have a angle between the current and the source current and the voltage, then you would have to use this particular formula, right? In this case, like it's very obvious that since both are in phase, the current and the voltage, uh, we will only have the active power, and the reactive gets cancelled by the capacitance and inductance by themselves. So everyone has followed this? Then we can move to the next question.
Yes,
Yes,
ma'am.
ma'am.
Ma'am, I have a doubt.
Yes.
Ma'am, in RMS value of voltage and current, B will not take an angle, I think.
Sorry.
Ma'am, in RMS value of voltage and current, we will not take angle like 45 or other.
Like why shouldn't you?
Ma'am, I think RMS value is a VMY root 2, right?
Yes, yes. It is the maximum peak value by root 2.
Yes. So we need to take an angle.
So in this like this is kind of a sinusoidal analysis, right? Like you can write this as 50 cos of 45 degree plus j sine of 45 degree, like that, right? We are just writing for our calculation in polar coordinates.
Yes. Yes, ma'am.
So this is 50, like this is written in terms of the polar coordinates.
Okay, ma'am.
I think he was doubting like whether it is peak or RMS, but they have specified in that
Yeah, it
problem
is.
itself it is 50 RMS,
Yes,
not
yes,
the
and
peak.
also
So definitely it is.
just 50. So in
Ma'am,
the yeah,
for laser, ma'am.
sorry,
RS 50 degree.
your voice is breaking off, I think. Could you write it in the chat maybe?
Am I audible now, ma'am?
Yes, yes, you are.
Can we write RMS value in terms of phasor?
Okay, so like you can also write in terms of the peak value, right? Whatever the value will be, Since in the answer itself it is also asked in RMS, so I had not converted it to the peak value and written in the problem.
So 50 angle 45 is it is in RMS form.
So right now this value is given in RMS form.
Okay, ma'am.
Also in the question it is also asked to write IC, IL and IR in RMS. If this would have been peak to calculate the peak value, we would have converted it.
How would we convert, ma'am?
So like RMS to peak, like you anyway, like it will be written in terms of like cos or sine. This like instead of giving it in as shown here, it will be written like something cos of something omega t plus 45, like that it will be given. And like the VRMS, the peak to RMS value is VRMS equal to V peak by root 2 as far as I remember, right?
Yes, ma'am.
So if
Yes.
we like root 2 into RMS value, whatever it will be given, we can write it in terms of peak, V peak. Peak means the maximum like magnitude. Is it okay?
Yes, ma'am.
Okay. So any other questions?
Ma'am, I have one doubt, ma'am.
Yes.
Can you show me the second slide, ma'am?
Yes.
Uh, if you wrote the active power VI cos pi, ma'am, the voltage angle 45 degree, a
Yes.
current 45 degree. How
Yes.
could you minus, ma'am?
So this
45 degree
particular
minus?
phi, see, I have not written as theta. This particular phi is the difference between the voltage and the current angle. Like the voltage phasor and the current phasor, whatever will be the difference, that is given as phi. So suppose if,
Sorry, I get it, ma'am. The cos
yeah,
pi means power factor, the angle between voltage and current.
yes,
Exactly, ma'am.
yes,
Okay, ma'am. Thank you, ma'am. Clear, ma'am.
yeah, okay. Uh, Anything else?
No, ma'am. No, ma'am.
Okay. Then we shall move to the next question.
Yes, ma'am.
Okay.
Yes, ma'am.
So for the next question, um, a circuit having an inductance, capacitance and resistance connected as shown is given here. It has two sources. One is a voltage source, the other one is a current source. So the voltage and the current source are connected here. So what is given in the question is the voltage across the capacitor VC is written in terms of a constant and cos of some value with a angle, and again a constant and the sine of some omega t plus an angle, right? So what we have to do is calculate, like figure out what are this constant a, b and the angles theta and phi by compare it with the equation that we will derive from the question. And also there is like two conditions given, that theta and phi are both between plus minus 90 degree. So how are we going to solve this? Any suggestion?
I just thought of
My
superposition theorem, but
superposition
I am
theorem.
not sure.
Yes, yes, that's a very good idea, because since you have two sources and the circuit is pretty much simple, you can calculate, like you can just figure out the voltage using superposition theorem and then finally compare it with the equation that is given. Like the final voltage that you will get, you can compare it with this equation and figure out. So, can we start this? So for
The
super,
value of R is missing or something.
yes, the value of R is not given here. So the thing is, like in this particular circuit, you actually don't need the value of R. You can still go ahead and solve it.
Right. When the current source is open circuited, definitely R does is not needed.
Exactly, yeah. So if we apply superposition theorem in this, so in superposition theorem, each voltage or current sources is like basically each sources is considered one at a time, and the magnitude Vc will be calculated. Now, while considering one source at a time, the rest of the source will either be open circuited or closed circuited depending on whether it is a current source or a voltage source, right? So first, for example, we are considering this 20 sine 300t voltage source. So in this case, the circuit will be now in superposition theorem, the current source now will be open circuited. So this is 20 sine of 300t. Forty millifarad, and this is some R. So we now should calculate this Vc depending on this particular source. So how can we calculate Vc?
Voltage division rule use.
Yes. So Vc will be Xc by Xc plus XL into the input voltage. So can you guys calculate? So let's name this as Vc1. Since the net Vc will be summation of this Vc1 considering this first source and Vc2 considering this second source. So what is Xc?
Minus 0.833J.
Okay, yeah.
0.833.
Let me calculate, then we'll see. Okay, let's just calculate Xc and XL first. 1 by omega here is 300, C is 4 microfarad.
Farad.
So 1 by
Millifarad.
1.2. Sorry? So it is 0.833, right?
Yes.
Yeah. And XL is 300.
4.2.
Okay. 14 millihenry. Okay. So just plug into these values. Minus J into 0.833 by minus J into 0.833 plus 4.2 J. So 4.2 minus 0.833 comes out to be 3.367. I have gotten rid of this J because in the numerator and denominator it is there. So 20 sine 300t. So what is the value of Vc dash coming up?
4.95
4.92.
angle of.
4.95, right?
Yes, ma'am.
sine of
180.
because there is a negative sign here, right? So will it actually be 180? So let me just write it up to here. So the value that is coming up is minus 4.95 sine of 300t, right?
Yes, yes.
So if we are to like get rid of this sign, so it is 4.95. When is sign going to be negative? When it is in the, like, the like
Third
all
or
sign,
fourth.
right, in the third or fourth quadrant, sign is going to be negative. So we can give it as 180 degree, or like, since in the question what we can do is, in the question it is written in terms of cos, this particular part of the frequency related value is written in terms of cos. So why don't we simply write it in terms of cos? So we have this 180 degree.
Then
Yes, tell me.
maybe we have to write as minus 90 or something,
So like,
because they
so
have
the
asked it, that theta is in terms of in between minus pi by 2 and pi by
pi
2.
by 2, right?
You
So
can't write as minus 270 or something, minus 180.
so the thing is, we first
We
have
can
to
write
convert it
in terms of,
cos.
uh, yes,
And also, like, just look at it, like, it is not exactly like equal to is not given for minus 90. It can be equal to
yes,
plus
yes.
90. So writing it minus 90, maybe it's not the best option. So we can write it 4.95 sine of, like, let's divide this thing. Let it be
Uh,
90 degree
my,
plus 300t plus 90. Let's write it like this. So sine of 90 plus theta is cos of theta, right?
but in second quadrant, sign is positive.
Yes. So we are writing sine of, so this is kind of like this, right? Where did it go?
But our answer is negative, right? Then the purpose of changing the sign will not be.
So we had written in terms of like plus 180 degree we had written, right? So there are two ways you can do it. See, I'll get rid of this part. So this is the equation that you got, right? Either convert it to cos right away right now. You can write it in terms of cos, or you can write like, you can first remove the negative sign and then write it in terms of cos. Is it okay? So which way would you like to go? Since the question is written in terms of cos, it would be easier to compare and get to the theta. So like, I had first like gotten a value of theta, and then I'll write it in terms of cos. So just for now, don't worry about the condition right away. We will fix it at the end. So let's get rid of this minus sign, 4.95 sine of 180 degree plus 300t. We are writing it like this, okay? Now sine is always positive in the second quadrant. So sine of 90 degree plus theta. This is equal to cos theta. Because in the first and the second quadrant, sine is positive, right? So if we like just consider entire thing as theta, we can still write it 4.95 cos of 90 degree plus 300t. Can we write this?
Yes, ma'am.
Yes, got
Yeah. So now what theta comes out to be is between this particular range that is mentioned in the question. So theta is equal to we will compare the magnitude and at the end anyway, since both the the frequency of this source and this source do not match, actually this particular part which is given by the first term is actually the contribution of this first source. But anyway, let us consider Vc1 to be this now and keep it. For the next case, when we are considering the current source, so the voltage source will be short circuited. So this is the new circuit now. So the current that is flowing is 2 cos of 600t. This value of resistance is unknown. This is 4 millifarad and this is 14 millihenry. Now to calculate this Vc, actually you do not need this value of R, because the current that will be flowing through here, you can easily apply current divider rule and calculate the current flowing through this particular branch and this particular branch, right? You have the
Yes,
total
ma'am.
current, you can use current divider
yes.
rule. So you don't really need this value of R and you can still get to Vc. So, so let's name this as Vc2. So what will it be equal to? In case of current divider rule, like suppose this is, I'm just showing simply for a resistance. Suppose this is a current source. This is the total I. This is R1 and this is R2. So this is I2 and this is I1. So the current flowing through a branch I1 will be in the reciprocal of the resistance, right? It will be R2 by the total R1 plus R2 into I. You know this, right?
Yes, ma'am.
Yes. So in this case, similarly, so first let us calculate the current, then we can calculate Vc. So let's say IC2 we are calculating. So what will be the value of IC2? Just in place of resistance, we will put
Minus
the, yes, ma'am.
0.4167 J.
You're calculating, you're talking about the net IC?
Yes, ma'am.
Okay, okay. Yeah, we'll get to that.
No, ma'am.
Yes.
I see 2.104 cos of 60 T.
Okay. Anyone else got the same value? Just tell me IC in terms of like the like capacitive and inductive reactances. It is? This is the total current that is flowing, right? The total source current. Now it will get divided into the two branches as per reverse ratio, right? The current that is flowing through in through the capacitor branch with the capacitor is XL by XL plus XC, right? Is this okay?
Yes, ma'am.
Yeah, right, ma'am.
So it will be What did you have for Excel?
Ma'am,
Yes.
ma'am, I have one doubt, ma'am.
Yes. Tell me.
Ma'am, we used superposition theorem, ma'am.
Yes.
First, we removed the current source.
Yeah.
Okay, ma'am.
First, we
That
considered
time
only the
we
voltage
used
source.
okay, ma'am. First step we used only voltage source. The
Hmm.
voltage source have 300 T. We used omega as a 300. In second step, we used only current source. The
Yes.
current source have 600 T.
Yes.
Can again find out XL XC in omega used 600, or we already find out the XL XC.
No.
Which XL XC is used, ma'am?
No. In this case, like since we are considered one source at a time, we have to calculate the XC and XL according to
One
this
second.
current source. That is why I kept asking like what is the value of XL and XC?
Oh, sorry, ma'am. I can't
Yeah.
hear your voice.
Oh,
Okay, ma'am.
XC, ma'am, minus J 0.416.
yeah. So the thing is, whoever was asking before this, like since we are considering this particular current source now, so now omega is actually 600, right?
Excellent. Yes, ma'am.
So xc will be 1 by omega into c, this omega into c. So this is like, let's consider this xc dash. It is like not correct to write in terms of xc. That is why we had used superposition theorem, because this would make the solution easy, right? Considering one source at a time. So this omega dash, okay. So this will be 1 by 600. C is 4 millifarad. So this is 1 by 2.4, right?
Yes, ma'am. My doubt clear, ma'am. Thank you, ma'am.
Yeah.
I I will find out myself in Excel, ma'am. No problem, ma'am.
Yeah.
Ma'am, I have one more doubt, ma'am.
Yes.
In previous one, we find out the I, ma'am, 0.5 angle 45 degree.
Yeah. In the previous question?
Yes, ma'am.
Yeah.
Previous one, ma'am. We find out the J turns into, sorry, minus J turns into minus 90 degree, ma'am.
Yes.
But now you find out the minus j turns into 180 degree, ma'am. How, ma'am?
So could you repeat like minus j, where did I write 180?
Ma'am, in previous one, ma'am, we find out IC.
Yeah.
Okay. The IC, in denominator, we have minus J8.
This one, right?
Yes, ma'am, yes, ma'am. In
Yeah.
between, the green color below.
Yeah.
If the minus J8, the 8 comes, ma'am, minus J turns into minus 90 degree.
Yes.
Okay, ma'am. In second sum, the voltage, we find out the voltage VC.
So you're talking about this minus sign. How did I get to 180?
Yes, ma'am. Again the minus j comes here, ma'am.
So
How it
so
would change 180 degree, ma'am?
so this is not minus j, right? This is minus 1.
Minus.
So there is difference between minus z equal to minus j and z equal to minus 1, right?
Okay, ma'am. How?
J and J in the numerator and denominator gets cancelled and we are left with only minus sign.
Yeah.
Sorry, ma'am. Sorry, ma'am. I
This
never.
particular j and
Sorry,
this
ma'am.
two
Clear,
j.
ma'am. Clear, ma'am. Sorry, ma'am. Sorry, ma'am.
Yeah.
I wrote the notes. I missed the J, ma'am. Sorry, ma'am.
Okay,
Sorry, ma'am.
okay. I see, I see.
Thank you, ma'am. Thank you, ma'am.
Yeah. So, where were we? Okay. So we calculated XC and XL, right? XL will be uh, omega is 600 into 14 into 10 to the power minus 3. So 14 into 6.
8.4.
Okay. 8.4. So we have 8.4 J by 8.4 J minus 0.4166 J into 2 cos of 600 T. Similarly, I am cancelling the J here too, okay? Please note 8.4 by 8 minus 0.4166. So somewhat 7.9834 into 2 cos of 600t. Or by answer, what does this come out to be?
2.104 cos of 600t.
Cos of 600t. Okay, now so let us see in the question, it is written in terms of b sine 600t plus 5, right? So how can you write this in terms of sine? So okay, we have only found the current, we need to find the voltage. So VC is equal to XC into IC.
Yes, ma'am.
So what is XC? It is minus J into 0.4166 and IC is into 2.104 cos of 600t, right? So this into 0.4166 minus 8766. So it is minus J 0.866 cos of 600t. Now we need to get rid of this J part and write it in terms of angle, right? Can we do that?
Yes.
So minus J is equal to again
Minus 90 angle of.
minus 90 degree, right? So
Yes, ma'am.
0.866 we can write this as cos of 600t minus 90 degree. If you are to write in terms of, let's say, sine, anyway, we also know that cos of minus theta is equal to cos theta, right? Is it
Ma'am, I
correct?
have, ma'am,
Yes.
ma'am, I am not understanding how to convert this.
Okay, I'll just let me open up a slide. So you have z equal to a plus jb, right? This is kind of written in terms of this is the real part and this is the imaginary part.
Yes, ma'am.
Now if you are to write in terms of polar coordinate, that is mod of z into angle of z, this theta is given by tan inverse of b by a, right? Because if this is the real axis, this is the imaginary axis, whatever the value may be, this theta will be given by this this by this, right? So this, suppose this particular thing is z, this is z cos theta, this is z sin theta, you know this, right?
Yes, ma'am.
Yeah, so this z mod z will be equal to square root of a square plus b square according to this, and theta will be equal to tan inverse of b by a. Now is this clear?
Yes, ma'am.
Now when we have only minus j, suppose this can be written as 0 plus minus
Ma-
1 into j, right? So
yes,
here
ma'am.
a is 0 and b is minus 1, right?
Yes, ma'am.
So mod of j will be equal to root over 0 square plus minus 1 square. So root over 1 is equal to 1. However, theta will be equal to tan inverse of,
B upon A.
so it is minus 1 by 0.
0.
So this is theta equal to tan inverse of infinity, but this is minus infinity. So it is
Yes.
minus 90 degree.
Okay, ma'am. Okay.
Got it?
Okay. Thank
So
you.
yeah, so instead of that, we are just simply like putting this minus j to be directly to be like minus 90 degree, right? So here, since the minus will come again and again, what we can do is, let's first write it in terms of sign. Okay, sorry, this one let me use the pen. So for this case, what we will do is, uh, let's keep the sign as it is. So it will be equal to minus 0.866. This will be only j. Only j we are trying to replace. Okay, so cos of 600t plus 90 degree. This is, we are not replacing minus j. Please note, we are replacing just plus j. Because we anyway need to convert it to sine, right? So is this okay with everyone?
Yes, ma'am.
Okay. So now cos of 90 plus theta is cos of 90 degree plus theta. What is it equal to?
Minus sin theta.
Minus sine theta, right? Because cos is negative in the second quadrant. 90 plus some theta. So this will be minus 0.866 into minus of sine of 600t. Now we can get rid of this minus sign. So finally VC becomes equal to 0.866 sine of 300t. Is this okay? Is this okay with everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So now that we have VC, this is VC2, right? Wherever I have written VC, this is the VC2. That is due to the second source. So the
Hello,
equation that,
excuse madam.
yes,
Just go to the answer, please. Answer.
yeah, I'm giving it. Wait. The final one?
Final one. Just taken 0.86 into sine of cos 600 cos of 600 plus 90 degrees
Yes,
is equal to minus sine 600. Okay. So
yes.
here we written 300t.
Oh,
Yeah.
sorry. Yeah, it should be 600.
Okay. Then okay. Thank you.
So I'll write it like properly in the next page. So yeah, so people joining this late, it won't be useful. Like we have already covered the two problems, but yeah, you can always go to the video. So the net VC will be equal to VC1 plus VC2, right? So VC1 we calculated it to be 4.95, 4.95 cos of 300t plus 90, and VC2 we have calculated 0.866 sine of 600t. We can write it as plus 0, right? So now we can compare it with the equation that is given and calculate A, B, theta and phi, right? So the final A will be 4.95, B is equal to 0.866, theta is equal to 90 degree, phi is equal to 0 degree. Is it fine?
Yes.
Okay. So somebody has put something in the chat. Okay. So this is all about the second problem. If anyone has any question, you can ask. Otherwise, we'll move to the third one. So in this case also you see this condition about the theta and phi are given. So in this case, had we not converted, like had we written in terms of minus 90 degree and added like plus something to convert it to sine, we might have come up with angle greater than like 180 degree. Like again, then you can get rid of it, because you see beyond 180 degree you can get rid of it, right? Suppose you had, like suppose while solving it, you may solve in various approaches. So suppose you have solved and you got something like sine of 600t plus 180 degree, right? If you had come up with this, then what you could have done? So break it into 600 plus 90 plus 90, or since in the question it is written in terms of sine, just write sine of 180 degree plus theta is equal to minus sine theta, right? You can write it like 180 degree plus theta means it will be in the third quadrant in which sine is negative. So it would have been minus of sine theta, sine of 600t, something like that, right? So however way you get the like solve the problem, make sure you look into the conditions. These conditions are given so that the answer like matches to exactly what is given in the question. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. So now we can move to the third question.
Yes, ma'am.
Okay. So in this third question, it is a star delta kind of a circuit that is given. Sorry, this is a star connected circuit that is given, and at each of the like phases there is an resistance, capacitor and an inductor are connected. The voltage is also given here. So what you have to do is calculate I1, I2 and I3, these currents flowing through these branches as shown here. So the condition again that is given is the theta lies between minus 180 degree to plus 180 degree. So how are we going to approach this problem?
Is it not simply I is V by Z, whatever it is? I1, I2, I3, just
Sorry,
divide directly with, just divide directly the applied that voltage with the resistance or
but
inductance or capacitance or get the
but
current flowing through.
but what is the voltage across this 50? For example, this 50 ohm resistance, what will be the voltage? Like you do not have the voltage of this side, right? In the branch, like how do you calculate? Like say, suppose if there is a resistance here and there is a voltage connected here, until and unless this is the only thing that is connected across it, you can't calculate it, right? In this case, suppose it is somewhat like this. Let me just use the eraser. So in this case, the circuit is kind of like this. And you have a voltage source here, here and here. And these are connected to the neutral. So you have the voltage at this particular node, right?
Okay,
Yes,
You do
ma'am.
not have the voltage across this particular node.
true.
So you need to have the voltage difference, then only you can calculate the current. So you're going towards the right approach. Uh, so can you suggest what you have to do?
By using KCL, ma'am, to
Nodal
find.
analysis.
Yes, exactly. So if you can figure out the voltage in this particular node, you can easily calculate all the branch currents. So the best option would be to use KCL.
That's correct.
Yes. So could you please start? I'll give you a minute or two to start it off, then we'll start with solving together. So have you guys started? So if we apply KCL at this node X, what will be the equation? I1 plus I2 plus I3 will be equal to 0, right? All the currents are going into the branch. So if we write in terms of voltage, what is I1?
∠120 minus Vx by 50
Right.
or opposite of it.
Yeah. So we will write it as 50 angle 120 degree minus of Vx by the resistance 50. In case of the next branch, which has a capacitor, it is 50 minus angle of minus 120, again minus of Vx by minus J50. And the third current is 50 angle of 0 degree minus Vx by J50. This will be equal to 0. So basically you have to convert this polar coordinates into J form so that you can subtract or divide or whatever. So can you separate out the known and the unknown part? So yeah. So since we have to calculate Vx, what I'll do is, like, the rest of the part we can separate out. So this 50 120 by 50 plus 50 minus 120 by minus J50. So this J50, okay, let's write it for now. I'll do step by step. Plus 50 angle 0 by J50. And all the Vx terms which are in negative, so it will be minus Vx by 50. All this I will take it on the other side, okay? So it will be Vx by 50 plus Vx by minus J50 plus Vx by J50, right? I'll take this into a different page. So damn it. Okay. So this side of the equation, these two terms can be cancelled because it is minus Vx by J50 plus Vx by J50. So it is Vx by 50. In this side, like 50-50, let's get rid of. It is 1 into angle of 120 degree Then for the next one, 50-50 can be cancelled. In the numerator it is minus 120 degree. And what will be in the denominator? It is minus j, right? Minus j is equal to?
minus 90.
Minus
Right.
90.
Exactly. So it will be minus 90 degree. And for the third equation it is 0 degree on the numerator, and in the denominator it is angle is plus 90 degree, right?
90.
So let's write this Vx by 50 is equal to, now let's write in terms of like the like I like a plus jy. So this can be expanded into cos of 120 degree plus j sine of 120 degree, like that, right? So I will just write the values directly. So let me use that. So cos of 120 degree is minus half, right? And sine of 120 degree is root 3 by 2. So before this we should write another step. So do join in time because we are like kind of doing the last problem, but okay. So let's write this particular step where Vx by 50, this is equal to 1 into 120 degree plus, so if I take it to the numerator, what will it be? So if we have in polar coordinates, this is theta 1 and this is theta 2, the net theta will be equal to theta 1 minus theta 2, right? So if I take this minus 90 on the numerator, it will be plus 90, so it will be minus 30 degree, right? And the third one, it will be 0 minus 90 degree, that is minus 90 degree. So now from this to this step, so for the cos 120 degree plus j sine 120 degree, now cos of minus 30. So cos of minus 30 is cos of 30 and cos of 30 is root 3 by 2. Now sine of minus 30 is minus sine 30. So minus of half, right? Now again cos of minus 90 is equal to cos of 90, which is equal to 0. And cos of minus 9 sine of minus 90 is minus sine 90, that is equal to 1. Is this clear? So Vx is equal to 50 into, let's like take out the j and I part separately, so it is root 3 by 2, this is one part, and minus half. So it is root 3 minus 1 by 2 plus j, it is root 3 by 2 minus half and minus j. So it is root 3 by 2 minus half minus 1. Is it fine?
Yes, ma'am.
So we can either simplify Vx in term like simplify all this and calculate the exact value in terms of x plus jy, or we can keep it like this because it will simplify our calculation, because the rest of the term when we are to calculate the current or anything, it is written in terms of 50 plus some 50 angle of something like that. So let's just keep it like this, 50 into root 3 by root 3 minus 1 plus j. This will be, if we just take the numerator as 2, it is root 3 minus 3, right? This is Vx. Now let's calculate the first branch current. Here it is I1.
Ma'am, I have one doubt, ma'am.
Yes.
Ma'am, cos 90 0. I okay, ma'am. How
Hmm.
cos, ma'am?
Yes.
I have 120 degree, minus 30 degree, minus 90 degree. Okay, ma'am.
Yes. Yes.
Why cos, ma'am?
So see, like, suppose you're given a value Vx equal to, let's say, V naught angle of theta.
Yes, ma'am.
So this is the magnitude and this is the angle.
Yes, ma'am.
So it is V naught cos of theta plus J sine of theta. V naught will be there. This is what I have been trying to tell, right? Like, if there is a phasor here, this is Vx. It
Clear,
is,
ma'am. Clear, ma'am. Clear, ma'am.
yeah.
Yes,
So
ma'am.
this like, I'll just use the highlighter, wait.
Now I understand, ma'am.
Okay, this part are
Yes,
the
ma'am.
cos part and the unhighlighted ones are the sine part.
The real part is cos. The
Yeah.
imaginary part is sine.
Yes, yes.
Yes, ma'am. I clear, ma'am. Clear.
Okay.
We can move next, ma'am.
Yeah. So we have Vx. Now we should start calculating x1, x2 and x3, right? Sorry, I1, I2 and I3. What will be I1? I1 will be the voltage across, the voltage that is given minus V of x that we have calculated by the resistance, right? So it is 50 angle of 120 degree minus Vx by 50. This is I1. So can you guys calculate this? We have now Vx, right? So we can write it as 50. Then cos of 120 degree is minus half. Sine of 120 degree is root 3 by 2. And we have the value of Vx now, right? 50 into root 3 minus 1 by 2 plus j root 3 minus 3 by 2 whole by 50, right? So 50 we can get rid of and write it in terms of the fractions only. So it is minus half plus j root 3 by 2 minus of, so if we bring this one out, so it is minus of root 3 by root 3 minus 1 by 2 minus j of root 3 minus 3 by 2. So we club this j part together and the rest of the part together. So it is, let's take it to the next page. So if anyone has done, you can dictate, otherwise I'll just write it. So minus half minus half, and then there is minus root 3 by 2, then so this minus and this minus will become plus, so it is plus half plus j terms, let's write it. So it is root 3 by 2 so root 3 by 2 minus of root 3 by 2 and we have plus of 3 by 2. So these two terms will get cancelled, these two terms will get cancelled, it will get simplified to minus root 3 by 2 plus 3 by 2 j, right? So suppose we take root 3 common, what will it be? Minus half plus root 3 by 2 j. So can you calculate the magnitude and angle of I1 now? If we are to write I1 is equal to some magnitude into angle, what will it be? Angle you can directly find out, right?
120 degree, ma'am.
Sorry? Yes. So it is tan inverse of root 3 by 2 by minus half. Tan inverse of minus root 3. So this is 120 degree, right? And what will be the magnitude?
Root 3.
Exactly. So it is root 3. So we have this is equal to root 3 is 1.7 something, right? 1.732. Angle of 120 degree. So similarly, can you find I2? It will be exactly the
Yes.
same. Sorry? You have this Vx here, you have the voltage here. So it is the same procedure. Can you please calculate and let me know what is the answer? I'll maybe give a minute or two, then I'll start like solving. In place of Vx, you can already put the value. Whoever has their mic like not muted, please mute yourself. So you guys are solving, right? Okay. So again, you can get rid of the 50 from numerator and denominator. And what is cos of minus 120? Like this minus 120 degree, you write it in terms of I and j, right? So what is cos of minus 120? Anyone?
1 by 2. 1 by 2.
Why is it 1 by 2?
Cos of, oh, okay. Also.
So cos of minus theta is equal to cos of theta, right?
Cos theta, right? 1 by 2, minus 1 by 2.
Yes, cos of 120 degree. So it is minus 1 by 2. And sine of minus 120 degree?
Root 3 by 2 only.
It's minus root 3 by 2. So make sure you take care of the signs, okay? This, like in this kind of problem, it will be very
Okay.
prone to making mistake.
Okay. Minus.
Just like do step by step, like sine of minus theta is equal to minus sine theta, and here theta is 120 degree. So 120 degree means it is lying in the second quadrant, right? So 120 degree will be somewhere around here. So in this case, all the signs are positive. In this case, sine is always positive. In this case, tan is always positive. And in this quadrant, cos is always positive. So figure out which quadrant it lies, and that will be easy to. Is that fine? Then you can calculate the rest of the thing. So it is minus root 3 by 2. So it will be plus half minus root 3 by 2j plus 3 by 2j. And denominator, so 50 is gone, so it is minus j, right? So let's get rid of this minus sign and take it up, and remove, club the imaginary and real separately. So we have this minus half, we have this, and we have this. So minus and plus half will get cancelled. We have minus root 3 by 2. Then in the imaginary part, we have minus 2 root 3 by 2. And we have plus 3 by 2. So let's 3 by 2. J by minus j. So let's just get rid of this minus part first. So it will be root 3 by 2 plus 3 minus of 3 2 root 3 by 2 j by j. So now we can write it in terms of values, right? It will be root 3 by 2 is 0.866.
0.89, angle of 74.
So the final value?
Yes, ma'am. I2.
Okay. I2 is like, let me see. 89, 0.89 angle is minus 74 point something, right?
Yes, ma'am.
Okay. Yes, it is correct. So we will, since one of you have completed, we'll just solve this one. So it is 3 minus 2 root 3 by 2. This comes out to be minus 0.232j by j. So it is basically I2 is 0.866 plus this minus and minus will become plus 0.232 by j. Now we convert it into polar coordinates because you have to get rid of the denominator. So the magnitude of this will be square root of 0.866 square plus 0.232 square, which is 0.896 and angle will be tan inverse of 0.232 by 0.866. This will be theta. So tan inverse of 0.232 divided by 0.86. So it is 14.99 degree. And in the denominator it is j, so j is equal to 90 degree. So when we simplify this, it is 0.896 angle of 14.99 minus 90, which comes out to be around minus 75.01. So around minus 75 degree. Everybody clear on this one? Has everyone calculated this?
Yes, ma'am.
Okay. So make sure you calculate it properly, because like this numerical is very straightforward, but it is like a lot of minus sign here and there will come up and you might make a mistake. So like solve it systematically and carefully. Now for the last I3, can you calculate?
0.89 angle of minus 45.74.
Yes, it's correct. So everyone else has calculated? So you guys are doing it, right? Whoever are there? So can anyone start solving with me? So what will be
Yes, ma'am.
I3? Yeah.
I3 0.89 angle of minus 45.74.
Yeah, that I got it. You got the answer. So I'm just like asking someone else, or maybe you also, like just to start solving with me. So this is I3, right? So 50 minus 50. So it is root 3 by 2 minus half plus j root 3 by 2 minus j 3 by 2 by j into 50. So we can get rid of this 50. 1 minus root 3 by 2 plus half j root 3 by 2 plus 3 by 2j. So if you simplify all this, so it is 3 root 3 sorry 3 minus root 3. So this half plus 1 becomes 3. So it is 3 by 2 minus root 3 by 2. So 3 minus root 3 by 2. And if we club the imaginary part, it is j into. So it is 3 minus root 3 by 2. Right? And denominator it is j. So let's extract. So I3 is equal to 3 minus root 3 by 2. We are going to take it out. So it becomes as simple as 1 plus j by j. So can we write it in terms of polar coordinate? So denominator will be, what will be the denominator? Can you calculate the magnitude and angle of the numerator and denominator? I would really like encourage someone else to try, like whoever have not done, because in the assignment you have to solve on your own, right? Please let me know. Like, so how will we write 1 plus j in terms of polar coordinates?
The angle 45 degrees, madam, numerator.
Sorry?
The angle 45 degrees numerator. Denominator 90.
Yes. And the magnitude?
Magnitude have to calculate.
Magnitude will be like root over 1 plus 1. 1 square
Yes.
plus 1.
Yes, exactly. So the magnitude will be 1 square plus 1 square, and the angle will be tan inverse of 1 by 1. So it will be root 2 angle of 45 degree. And in the denominator it will be 90 degree. So if we just simplify this, it is angle here will be minus 45 degree, and it will be 3 minus root 3 by 2 into root 2, which comes out to be 0.8965. So this is equal to I3. So everyone has gotten it?
Yes, ma'am.
Okay. So anyone has any doubt? And I1 we had found out in the earlier case. It was something into 120 degree. 1.732. Okay. So anyone has anything to ask in this question? So you guys are more or less getting it, right? Can anyone respond like with a yes or
Yes,
no?
ma'am. Clear.
Yeah. So all these three questions are clear. I hope this will be able to help you in the assignment problems that you'll have to submit.
Yes, ma'am.
Yes, ma'am.
Okay. Anything specific you want to ask? Or else maybe we can like solve one of like with respect to a previous problem, like if anyone is interested, we can solve one short problem on like switching from the previous section. Would you like to do this or end the session?
Just a small doubt, madam.
Yes.
How the angle minus pi by 2 something is given earlier, second problem, what you said, minus pi by 2 less than theta less than pi by 2.
Yes.
How the condition is concluded generally?
So there are several approaches to solve this problem, right?
Right.
Like in this case, I'll just take the laser. 1 second. So when we converted like this minus sign and put it as 180 plus 30 and then finally converted it to cos, instead of that one might first convert it to cos and end up with an angle of like greater than 90 degree, right? So you have to like simplify and bring it back so that the angle is between the range that is given here. It is just to make sure that the conditions given in the question, we are satisfying that and that exact angle we are calculating. So for example, in the B part, like B sine of 600t plus phi, instead of phi one might get as 180 degree, because anyway like or maybe 360 degree, you never like, so sine of 360 plus something will itself be sine of that angle itself, right?
Yes.
So the range of phi will be varying, right? But in the question it is a numerical based question, so it will be like a particular range will be given as the correct answer. So these conditions are given to
Yes, yes.
ensure like they match it.
Okay, okay. The finding theta or phi value also must be in that condition only.
Yeah, and anyway like in certain circuit conditions, like in real life what happens is like the inductive or capacitive voltage may vary like in phase up to that particular, like this is I'm talking about from numerical point of view, but in real life like the phasor angle can be at most of that much difference to be able to like satisfy that circuit conditions. So because of that this circuit conditions are given, like in real life scenario I'm talking about for any circuit.
Thank you. Thank you.
Yeah. So, so anything else to ask?
Nothing, madam.
Okay. So, a small problem like we have done previously. Can you like I guess you have done the assignment also. So can you quickly solve this question? So these are the two switches that are given. They are alternately closed. Like initially this first switch will be closed and the second one will be open. Then after 0.1 second, the second one will get closed and the first one will get open. So what you have to do is calculate, sorry, this is VC and VR. So you have to calculate the voltage across the, so maybe even calculate one if time is there. So calculate one of the voltages after 0.1 second. Can we do that? So initially the capacitors are uncharged. So VC is 0. So can you tell me like how to solve this?
So initially it is a S1 is
So initially both of them are open and the circuit is like not functioning. So the VC is also 0 at time t equal to 0. At exactly time t equal to 0, this particular S1 has been closed. So now the circuit kind of looks like this. So yeah. Okay. This is 1 microfarad. This is 100 kilo ohm and the voltage is 100 volt. So at time t equal to 0.1 second, what will be the value of VC? Let's calculate only VC for now. Now after just at time t equal to 0.1 second, what will happen is the switch S1 will open and this will close.
okay.
Anyway, we'll come to this later, but first what will happen after time t equal to 0.1 second? What will be the value of VC? So do you remember the equation? Like
V into 1 minus e power minus t by tau.
yes.
100 into.
So capacitor, like whenever like suddenly a voltage source is connected across this capacitor, it will not change instantaneously, right? It will gradually increase. So initially it was at 0, so it will slowly increase and reach a certain voltage. We have to calculate this VC at time t equal to 0.1 second.
99.9, is it right?
No, like it's raised to the power e something, right?
E power 0.1 seconds. Oh, wait. Sorry.
So at t equal to suppose 0 minus, just before switching VC was equal to 0, right?
Yes.
Now if like the question was not about 0.1 second, like if the switch was closed after at time t equal to 0 and the circuit would have completed itself, so what would have happened is like this entire 100 volt would have come across this 1 microfarad voltage, right?
VC at 0.1 seconds is 63.2.
Yes. So would you like to solve this, or you guys have solved it already, apart from whoever has answered? So
VC is equals to 63.2, VR is equals to 36.8.
yes, it will be 100 minus that.
Remember that.
So yeah, so it is 100 e to the power minus t by, and here tau is equal to 1 by RC.
Yes. RC, tau is equal to RC.
Oh, sorry. So it is 10 to the power minus 6 into 10 to the power 5, that is 10 to the power minus 1. So it is 10 to the power minus 1. So 100, 1 minus e to the power minus 10t, and t is 0.1 second. 100, 1 minus e to the power, it will be minus 1, right? So this comes out to be 63 point what? Somebody has solved it, right? 63 point?
The value at 0.1 seconds, VC value 63.2, VR value is equal to 36.8 is correct.
Yes, yes. VC becomes 63 point
2.
some value 2, 2, 3, something like that, and VR will be equal to 100 minus VC.
Yes.
So when switch S2 will be closed, what will
Yes.
happen?
It is discharging.
It will start discharging through this
Discharge.
circuit, right?
Yes.
So again at t equal to 0.2 second, what will happen? This switch will open again and S1 will be closed. So the waveform of VC will somehow look like from 0 to, it will go to 0.63, then it will come back to a certain value that
Yes.
you can calculate by putting t equal to 0.2 and subtracting like the initial voltage that it had. Now it has an initial voltage of 63.2, right? Then you can calculate this value. If it does not go to 0, then it will start increasing again slowly. The voltage waveform around VC will be somewhat like that. Is it fine?
Yes.
Do you have anything to ask? It is 63.21, right? Let me just write it.
51.7.
Sorry. Huh?
51.7.
So you have subtracted the initial voltage it had, right? Like it will discharge from here to here. So in this case, the initial voltage will be what we have at e to the power minus 1. So the net decrease in voltage, the net discharge will be whatever at time equal to t equal to 0.1 second, whatever it would have been, that has to be subtracted from t equal to 0.2.
Yes.
So whatever
Okay.
that value is, that will be the value after 0.2 second, and that cycle will repeat like again. Then S2 will be closed and S1 will
In
be
this,
open, and will go.
actually, in the sense that how to write that expression VC at
So
0.2 is equals to 63.2 into e power minus t by tau. Is it right?
so yeah, so initial voltage of the capacitor now like at so
63,
V0.
63.2.
Yes, yes,
63.2 into e power minus t by tau.
right.
Tau is equals to zero point 0.1.
Tau now is equal to like, yeah, 0.1.
And t is equals to zero point 0.2.
Yes, yes.
So after that, you get that a solution e power minus t is equals to 0.81 something.
Okay.
Point,
Yeah,
point, 0.81 into 63.2 is equals to 51.7.
I see. Okay. So I'll just, so now like when the current like it is getting discharged, so now let me use a fresh, so from t equal to 0.1, now then t equal to 0.2, 63.2 volt is there, some resistance 100 kilo ohm. Now this current is like this capacitor is slowly getting discharged. So at t equal to 0.2, it will be, so let's calculate at t equal to 0.2 what will it be. So it is 63.2, 1 minus e to the power, so it is 10.
Here there is no source, no?
So now there is no source, so like we have to subtract, like you can either calculate it like at t equal to 0.2, and then whatever the value is, like you take the difference between how much discharge it will take, so that will be
Okay.
like whatever the Vc at 0.2 minus Vc at 0.1, this one you
Okay.
have to find out.
Okay. Okay.
So it comes out around 0.23 something volt. You guys can try this out. We will like
What would be the answer, please?
answer is around let me see, so it is around so it will be 23.3 volt.
How would you know that 60.63? That's okay. Point 1 minute, please. This one is 51.7. How would you get this 23.3?
So this Vc at point 2
Hmm.
we are calculating, and then like how much discharge, like now since there is no external voltage source, this is the
Yes.
initial capacitor voltage source, right?
That's
So
right.
it is like at 0.2, like how much voltage it will go to, it will be how much discharge it has occurred, like.
Okay.
So either you can calculate in terms of voltage or in terms of current, and then you can like equate like subtract it from what it was at t equal to 0.1.
Okay. So T is equal to 0.1. Already you have calculated.
So initially what had happened was that at t equal to 0 the capacitor voltage was not there.
Yes.
Then at t equal to 0.1, an initial v of 0 is now no longer 0, it has a certain value, right?
Okay. Yes.
So now considering that only discharge, like having no external voltage, only like 63.2 e to the power minus t by tau, I guess it will be
Yes. Right. I think it is right answer. That one 63.2 T by
63.2, let me just calculate it, like e to the power,
minus T
so,
by tau.
so it will be minus 2, right?
Hmm.
So 63.2 e to the power minus 10 into 0.2. So this will be the net total discharge that had occurred. .55 minus 63.2. Sorry, so it will be 63.2 divided by e to the power. So taking this time 0.2 is actually not correct here. Why? Because right now, like the initial time t equal to 0 is actually t equal to 0.1, right?
Yes. Yes.
So instead of this, what we have to do is Vc will be equal to 63.2 e to the power minus this particular t is actually just 0.1 second, that is 0.2 minus 0.1, because it gets only 0.1 second to discharge, right? Not 0.2 second to discharge.
Yes, yes.
So that is why writing t equal to 0.2 will not be correct. So it will be 63.2 e to the power. So 1 by tau is 10 and t is 0.1.
Okay.
So let's calculate 63.2 into e to the power minus 1, right? This comes out to be 23.249 volt. Is this fine?
23.2. Okay.
Yeah.
Okay. Okay.
So that's how, like, again, this is an initial voltage now. Like for the next cycle, when again the switch S1 will be closed, then the capacitor will have an initial of 23 point something voltage, and you have to calculate now for the time fraction of again 0.1 second. Although now like time has elapsed to 0.3 second, but for only 0.1 second it is charging. So you have to calculate according to that particular like delta t, how much it is charging, then again the reverse cycle of discharging happens. So through this problem I just wanted to show, like, taking t equal to, like, what exactly this t value will be is actually the time duration whether it is charging or discharging, and not the absolute time, because absolute time for a certain switching is actually changing, because when this switch has been closed, the time t equal to 0.1 is its 0th time. Did you get the feel of it, like what I'm trying to say?
Yes. Yes. Correct.
Okay.
Right.
So yeah, this question was like last tutorial I had missed any kind of question like this, so I had put up this one. So anything to ask? Otherwise we can wrap it up for today. Anyone
Okay.
has
Nothing.
anything to
Nothing.
ask?
Nothing. Nothing.
Okay, then I'll stop the recording.
Yes.